Yeah. Are you ready? Can I say it? Okay, so it's all lowercase. IHM, IHM, and then SJH, and then 6. Yeah. Okay, guys, these questions they are working. So y asymptote is that 3, x asymptote has a different sign than in the equation. And then y-intercept, you make x equal to 0. Type it in, you get 1. X-intercept is the one that's more working, so you make y equal to 0. You move that plus 3 over, becomes negative 3. You times by x minus 1. You then divide by negative 3. And then you minus 1. Right, those are all the steps, so you get a third for that one. Then, when you plot your points, oh, I never labeled that x-intercept there. So when you plot your points, guys, obviously you draw your two asymptotes to cancel that, right? That is the y-intercept. The x-intercept is over here. What was it again? A third. A third and 0. So both of the points were on this part of the graph. So we had to find the point on that part. So guys, what you do is, it's not as simple as with the exponential graph, for example, which is the last one that we did. So let's just go over this again. You need 1 point, or you need at least 1 point on the left of your asymptote, which is at x equals 1. And then you need another point on the right of the asymptote, which is x equals 1. So now you can't sub in x equals 1, guys. Normally we do -1 and +1, right? If we do that now, it's not going to work. You have to sub in a point that is on the right of 1. So a number that's bigger than 1. Okay, so I subbed in 2. Okay, I have to show you the working there. But you can also choose any point. You could have subbed in 3 or 4 or 5, whatever. I just went close to 1, so I went 2. And I got the point 2, 5. Yeah, it's not for this one. It actually depends on the asymptote. Okay, then I also asked you about domain and range. So I just add that everything to that. For hyperbola, it's quite straightforward. It's always going to be the same kind of layout for the domain and range. So for x, it's always x element of real numbers, and then you just say x is not equal to the asymptote. All right, so which was 1. And for the range, it's always y is an element of real numbers, and then again y is not equal to 3, which is the asymptote. Good question on this one. Was a graph and was that issue with the x that you actually couldn't solve. So I still did the working, but I did just tell you guys in class what the equation was. So here for the exponential graph, the horizontal asymptote or just the asymptote is at that value always, so I think it's 1. For your y-intercept, you take your whole equation, you just make x equal to 0. Right, and we've got a value of 2 there, it was supposed to be a value of 2. Because it's 3 times 1, right? 3 times 2 is 0, so this is 3 times 1. So 3 minus 1, which is 2. For the x-intercept, this is what you would normally do, guys, and usually you will get an equation that actually works. Okay, it's just in this case now, I just took one from the textbook, and my intuition was a bit off because I had shown one that couldn't actually solve. But you would make y equal to 0, move that minus 1, it becomes +1, divide by 3, and then you would have to make a basic. And I think I did say in the trick, I'm going to teach you how to solve for the exponent if you can't make the basic. Okay, I have to use logs. Okay, but yeah, don't know how to do that yet. So I just told you that the x here was negative 1.58, which is a negative value. So for the exponential graph, you need a negative and a positive. So because you got a negative x-intercept, you have to choose a positive x value. So I just went with positive 1. Again, it's the simplest one, the easiest one. And then you got that 0.1 and 5. See? It's a small. Oh, wait. Thank you. Okay, then that is what the graph should look like, guys. If you could just make sure that you have that there. So you have your asymptote at negative 1. You have your x-intercept, y-intercept, and that third point. And then also just make sure that you have the domain and range there at the bottom. Domain for an exponential graph, always x element of real numbers, guys. It will never be anything different. Your range, you're going to have to look at your asymptote. Okay, so in this case, because the graph is above the asymptote, you have to say y is bigger than, greater than that asymptote. Can you say equal to negative 1 there for the range? Is it going to touch the asymptote ever? No. Okay, so you can't say y is greater than or equal to negative 1. You just have to say greater than. Guys, just letting you know, the zero rated server is apparently back up, so I'm going to start putting all the videos up. It'll take forever because there are about a million of them, but I'm going to start doing that today. But I know the test is coming up, so I'm probably going to it's next week Thursday, hey, you can start this one on time. But Monday, Tuesday, there's no school. And then like next week. Right. Oh, and I'm also not going to be at school on Wednesday. I'm going to a workshop. So we're finishing all the work. We're finishing all the work by Friday, and then Wednesday I'm going to ask. I was going to ask Miss Brown because she actually. I'll just get someone to sit with you, but I'll maybe record like a revision video or something. Yeah, I don't know if the data. Oh, but the zero at the server, you're not going to use data for that. And I'll leave some revision worksheets. You can just study them in that place. Okay, number 3, last one. I'm not sure if you guys have gotten to this one, but let's take a look for those that did. So this was a parabola. How do I know that it's a parabola? What in that equation is telling me parabola? The square. Okay, good. So that's a parabola. What order is that in? Turning point form. Okay. So we can get the turning point. We can get the turning point just by looking at this equation. Again, guys, the x bracket, the sign is different from the actual coordinate. Right? That's always the case. Whenever you have an x bracket in a graph, the sign is always different than in the coordinate. So it doesn't say x minus 2 here, it's going to be positive 2. But then just like with the hyperbola and the asymptotes, the y has the same sign. Okay, so the turning point is going to be positive 2 and negative 2. Y-intercept, you're going to make x equal to 0. You actually got the point 0, 0 as your y-intercept, guys. What do we call that point? It has a specific name. Origin. Now, because the origin is the y-intercept, it's actually also going to be one of our x-intercepts. Okay, you'll see now when you draw it off. It's not a problem. It's fine. To get your x-intercept, you're going to take your whole equation, make y equal to 0, and then solve for x. So step by step, that minus 2 becomes plus 2. Then you're going to say 2 divided by half, which is 4. Then you're going to take across that squared, and you have to do a plus or minus square root. Remember, that's very important. Whenever you take a square across, if you plus or minus square root on the other side, this negative 2 is going to become positive 2. So this is going to give you two answers, guys. Remember, you have plus 2, so positive 2 plus 2, which is 4. Alright? But then the second answer is going to be negative 2 plus 2, which is 0. Which gets you the same point as the line. That's fine. Not a problem. Any questions on the working group? And remember, I just showed you how to calculate x when your equation is given in turning point form. It's just a different way of doing it. But if you want to, you could have multiplied the brackets out and simplified the whole thing and got a trinomial, and then you could have used the quadratic form. I just think that would have taken longer than this way of solving it. Okay, but if you forget or you're not sure about this, you can always go back to the old way of solving it. Okay, can I go to the graph? All right, there we go. The graph looks quite simple because we have the same point as our y-intercept and the x-intercept, the origin there. Right, the origin is the only point that you don't actually have to label because you put that 0 around where the two axes are crossing. That is actually labeling the point already. So that 0 is saying it's 0 on the y-axis and it's 0 on the. Okay, so you don't have to still write 0, 0, 0. But you have your turning point 2, negative 2, and then you have your other x-intercept that you got, which is 4, 0. And then just make sure that you are also writing down the domain. Easy for the domain, it's also x element of real because it's going to either side with the arrow. For your range, you need to look at the turning point. Right, this is the smallest value that the graph can have, your smallest y value, which is going up from there. So you have to say y is greater than, but now we can also say equal to, because there is actually a point there. So greater than or equal to. Okay. Any questions, guys? Right, we are now moving on to finding the equation of a graph, and we're just going to do an example or two on each type. We'll see how far we get. So you can make a new heading, finding the equation of a graph. So I'm not going to do each graph separately. I'm going to do one heading for finding the equation. And hopefully from tomorrow onwards, we can start doing mixed graph. But I see you guys every day this week, so yeah.